Welcome to the fourth week of talks in the GCOOS Spring Webinar Series. The goal is to learn about the projects and the research that GCOOS is funding under our current IU's 5-year award. My name is Chris Simonello. I'm the Outreach and Education Manager for GCOOS. I'll be moderating today's session, which is being recorded. Jennifer Freeland will also be working with me to help monitor questions that you can write in the chat box, or you can raise your hand, and we'll be taking questions throughout the talks and also at the end of each presentation. First up today is Dr. Frank Muller-Karger. Frank is a professor of biological oceanography at the University of South Florida College of Marine Science. He's also the director of the Institute for Marine Remote Sensing, where activities are focused on the analysis of digital data and the development of applications from these data. Now, much of his team's research is focused on understanding how large-scale disturbances like climate change are affecting water quality, primary production, and biodiversity in coastal and marine environments. And Frank has been instrumental in enabling the integration of biological data into ocean observing through his leadership with the Marine Biodiversity Observation Network. He's been working tirelessly to create a community that converges on accepted standards for multiple essential ocean variables and essential biodiversity variables that can be used to evaluate resilience and vulnerability of ecosystems, and that includes people. More impressive than his many awards, including the 2021 William T. Pecora Award, sponsored by USGS and NASA, is his career-long dedication to education. And in the 3 decades that I've had the privilege of working with Frank, he's been laser focused on addressing the problem of underrepresentation of minorities in scientific research. And in fact, my personal interest in outreach and education was greatly influenced by the examples you've set, Frank. So thank you for that. Today, his talk is titled Advancing Products to Support Marine Life Studies and Management Assessments. And following Frank's talk today, I will introduce Dr. Nan Walker. So all yours, Frank.
Thank you, Chris, and thanks everybody for the invitation to talk to the GCOOS stakeholders and members. Many of you I've known for many years and decades, as Chris mentioned. But today, what I wanted to do is give a sort of a menu overview of some of the things that we have been doing with remote sensing over the years, but really lately. I'm not going to review everything that we have done over history. Let me know if you can see the screen. Okay, perfect.
Yes, it looks great.
Very good. So I'm Frank Muller-Karger at the College of Marine Science at USF, and St. Petersburg is there on the west coast of Florida, a little peninsula that sticks out to the Gulf of Mexico. The Institute for Marine Remote Sensing, we have a mission that we've taken up to understand marine life in general, but to also educate a new generation of scientists and inform the public about the ocean, and especially about marine life. And how do we organize information about marine life so that we can all make assessments and understand how life is changing in the sea. We do a lot of the remote sensing is applied in that sense, and so I'll mention some of the things that we're doing to try to understand those changes. My lab, 8, 12 people, it varies depending on who's visiting. We have a few graduate students. Right now I have 2 master's students, 4 PhD. We have 3 postdocs, and we always have a visitor or some other integrating person in the lab, but anybody's welcome to visit with us in our college. So today what I'll try to is jump it across many different scales. I'm going to stay more or less local, and I'll talk a little bit about what we're doing with the Marine Biodiversity Observation Network at the end of the talk. So I'll talk about the Gulf of Mexico, some of the basin-wide things that we've done over the years and how we keep it up to date. We've moved to the shoreline, to the coast, and looking at coastal vegetation, estuarine areas quite a bit, including looking at wetlands and seagrasses, and from Florida all the way to Texas. And we have also gotten engaged in the Ocean Decade, or the UN Decade of Ocean Science for Sustainable Development. And I'll mention that at the end of the talk. We published this paper a while back, like in 2015, but I've been updating and tracking what happens in the Gulf of Mexico. And with satellite data, it's very easy to do that. We have a full view of nearly every day of the entire Gulf of Mexico and the entire Caribbean. So it's relatively easy today to put together time series like these. And we go way back. We can go back to the 1980s with some of the satellite data. You'll see Nan will also describe some of these long-term time series. So we get synoptic views, we get frequent coverage and over a long period of time. So it's really a marvelous tool to see how things are changing. And so in the Gulf of Mexico, you can look at experiments like this. You can look at an area, a region of the whole Gulf of Mexico, coastal areas, deep water, and so on. And you can see what comes into the Gulf of Mexico and what goes out. So what I've been looking at is trying to understand the climatologies and how the Gulf of Mexico changes, and especially how it affects biology. So one of the basic things to do is, well, how is the temperature changing? And this is, of course, of interest to many people that do uh, some sort of resource management. And this is the typical seasonal cycle for sea surface temperature in the Gulf of Mexico. You have a minimum of temperature in the winter and a maximum sort of in August. And that is pretty much consistent throughout the Gulf. And what we see is that over these last 20 years, there's been about a degree of increase in temperature in the sea surface temperature of the Gulf of Mexico, in the interior of the Gulf of Mexico. If you move closer to the coast, that's a lot more variable. And what you're seeing in the plot down below are monthly means. And you see that most of the warming is happening, at least at this scale, and in that region in the northeast quadrant in the winters. So the summers, I mean, the Gulf of Mexico gets pretty hot anyway, so it's hard to get even warmer than that. But it does, you do find out on a weekly basis or daily basis that those temperatures exceed the maximum that you see here. We're also trying to do that for chlorophyll as a metric of what the biology is doing in general in the Gulf of Mexico. We find that the maximum in chlorophyll concentration at the surface happens in January. And that's true for all the satellites that we've looked at from the Coastal Zone Color Scanner in the 1970s and 80s all the way to today with MODIS and some of the other satellites that we have access to right now. Right now, there's a lot of satellites measuring ocean color and sea surface temperature, so it's a very rich data to look at. But what we see is that in the summer, the concentrations are very low, the water is very clear, and in the middle of the winter, especially in December, the concentrations are high. But there is no long-term trend. What we find is that maybe it's getting a little bit more noisy. You have some years, especially when the winters are very cold and there's a lot of wind, you have very large peaks in chlorophyll. But in general, there's no, we can't say that there's a long-term trend in the chlorophyll or in the primary productivity as measured offshore in the Gulf of Mexico, which is interesting, seeing that we see this trend in temperature. But the question is, you can play games and try to understand how and what drives chlorophyll concentration. So one thing that we did is look at other many parameters, including the mixed layer depth in the Gulf of Mexico, because it's not temperature that's driving the chlorophyll concentration, but it is the vertical stratification of the water column. And so the deeper the mixed layer, the more chlorophyll you're going to get, at least offshore. And for example, in that northeast quadrant, you have these little stars that go into higher primary productivity, but it sticks down to a kind of shallow mixed layer depth, and that is the Mississippi plume, and that makes sense. So you can almost predict the amount of productivity that you're going to see in the Gulf of Mexico if you know the mixed layer depth. Now, the other thing, jumping scales completely, one thing that we did is we had access to extremely high spatial resolution satellite data that is collected commercially by a company called Maxar or Digital Globe. And so we got onto a task to collect as many of the images that these companies collect from Florida to Texas. So all of these are counties that are mapped here, and we put them all on Google Earth Engine to map. In this case, we want to map changes in wetlands along the coastline, so coastal wetlands over many years, starting in about 2009. and see how things change and compare to other things. Like, for example, topographic map. So we constructed a digital elevation model from LiDAR data for this entire region and put it all on Google Earth Engine to try to see how things change over time and with topography. So this is available publicly. The link is there. The presentation is going to be made available. So you can go in, you can select dates, and then these counties will be illuminated with the type of vegetation types that you have that cover the ground. And we have all of these classes that you see, some scrub grass. We're now playing with mangroves and see if we can detect changes in mangroves. This is the kind of thing that you see if you zoom over, and with Google Earth Engine, you can slide this bar back and forth. On the right-hand side, you have the digital elevation model, a 2-meter resolution, and on the left-hand side, you have these land cover classes. And so you can go back and forth, and you can see how it changes with elevation and over time. An example, you can select two epochs or two periods. For example, you can select a period from 2009 to 2013. In this case, you're seeing a piece of Florida, and on the right-hand side, you have the same area, but 2014 to 2018, and you can compare the different types of land cover that you would find. And so all of that is available to the public. The reason that we went with these 2-meter resolution data is we were trying to look at how land change occurred over the years and compare that to water quality in estuaries like Tampa Bay, Charlotte Harbor, Sarasota Bay, and so on, all the way to Texas. And so we decided that, well, the land cover maps that are available at 30-meter resolution from the government are not really that good. We lose a lot of detail. And so we went to try to map that at 2-meter resolution. And you can see that it makes sense. You have a tremendous difference between the worldview data from Digital Globe and the 30-meter resolution that you typically get from Landsat down at the bottom. We also use the 30-meter resolution data. For example, we use Landsat and Sentinel-2 data. The Sentinel-2 series of satellites, there's 2 at the moment. There will be more. They're from the European community, and they have multiple bands that allow you to look at the water in a way that we had not been able to do before with Landsat. But Landsat provides a longer time history if you want to look at change. So here we're mapping seagrasses around Florida, and we're trying to do that for other places around the Gulf of Mexico and the Caribbean. So this is, again, in Google Earth Engine, all the Sentinel data, all the Landsat data, Sentinel-2, Sentinel-3, which is kind of an ocean color sensor. They're all on Google Earth Engine, and there's many tools to look at these satellite data. And you can construct your own algorithms like we did here for seagrasses. So you're able to do that over time. And what we did for Florida was we used Landsat and Sentinel-2 data to look at the time history of seagrasses in Tampa Bay and Charlotte Harbor and Sarasota Bay, for example. And here's an example that was published relatively recently, where we're comparing the satellite data to the ground truth collected by, for example, in this case, the Florida Fish and Wildlife Research Institute in the Tampa Bay Estuary Program. So at the moment, this time series is not updated, but now seagrasses, unfortunately, are starting to decrease again in Tampa Bay, and we're not really sure why that's happening. But at least we can map seagrasses more frequently than by going into the field and doing it with divers. Another thing that we're doing, this is jumping back to the scale of the Gulf of Mexico with data that cover the entire Gulf of Mexico with temperature and ocean color data, is producing these dashboards. One of the things that we were involved in with the National Marine Sanctuary, the Flower Garden Banks National Marine Sanctuary, is they had a coral mortality event in 2016, and people didn't know why. And we saw that a big, massive coastal plume of turbid water moved from the areas around Texas, Houston area, all the way to the Flower Garden Banks, which never happens. But we saw it happening in 2016, and we were able to document that So the sanctuary asked us, well, can you develop a tool that tracks turbidity in the ocean and gives us an alert? And so we decided to put together this little scheme here. If you have time series of satellite data every day and you could sample them at these spots, you can see when something is coming across, and then it sends an alert. For example, if something is coming across dots 1, 2, and 3, then it sends an alert, and you can look at the satellite data more actively and see if it's moving toward the flower garden banks. Now, these dashboards, we have 3 of them right now. We have one for the flower garden banks. We have another one for the Florida Keys National Marine Sanctuary. And what we do is try to see, are there things like red tides or turbidity plumes moving toward the sanctuary? And the advantage of this is that it's kind of automated. The sanctuaries use it for their condition reports. We can see the satellite images we can see the anomalies. We pair that up with things like river discharge. So the dashboard looks like this, where we have a climatology for chlorophyll, for temperature, for river discharge, and you can see when you have anomalies. And the dashboard, it can be programmed to send you an email and wake you in the middle of the night if something is happening, for example. Okay? So a lot of this is happening under the Marine Biodiversity Observation Network. We're trying to understand what kind of indicators can we have or produce to see how life is changing. The holy grail here is to really try to understand life itself and biodiversity in particular, but also abundance and biomass of organisms, which sounds very easy to do, but it's extremely difficult because there's hardly any data, and especially hardly any data flowing in near real time. We have these cruises, and this is South Florida. You can see the Florida Keys and in Southwest Florida and Florida Bay. There's a cruise going out tomorrow that is going to sample this. We do this with NOAA, OML every couple months. FWRI is involved and a number of other groups, New College, for example, also. And so what we do is collect eDNA data, ocean color data, phytoplankton samples for taxonomy, and any number of samples. So to try to understand, now we have data that go all the way back to 2016 for some of these parameters. So kind of a long time series. We try to put that data into portals that we're constructing with the Integrated Ocean Observing System, and in particular with GCOOS and SECURA. In this case, this is an M1 portal where many of the satellite data flow in, but also the in situ data. I'm not going to go over this, but it's a very fancy interface that allows you to look at the multiple parameters. We bring in satellite data from different sensors, and we try to combine it together in a classification scheme and something that we call seascapes, where we cluster together similar ocean color, temperature, sea level parameters, and come up with these colored maps that you see on the top. And we try to compare it to the cruise data that you see in the bottom. For example, here's phytoplankton taxonomy, and we can see that I'm not going to explain it, but we're trying to validate that the specific seascapes have particular populations of phytoplankton, and by extension would have different populations of other organisms. One big effort that we're going through with the Marine Biodiversity Observation Network is trying to convince people to share biological data. And so we're working with this Ocean Biodiversity Information System and the Global Biodiversity Information Facility to develop standards. And GCOOS has been instrumental from the beginning, including when Matt Howard was there. Matt was one of the pioneers in moving data, and then Marion took it over to move data into specific standardized formats that can be pushed out to ERDAP and then internationally to the OBIS database. So the idea here is to have standardized data that then can be harvested by anybody multiple times and put into different tools like these indicator cartoons that we have at the bottom. All of this is a continuity, starting with the Global Ocean Observing System that started talking about including biology and ocean observing way back in the 1990s. And it's an evolution that has taken a long time. We went through the Census of Marine Life in the 2000s. That went away and we established the Marine Biodiversity Observation Network in 2014. And now we're sort of having these partnerships under the umbrella of the UN Decade of Ocean Science for Sustainable Development in a program that we call Marine Life 2030. And everybody is welcome to participate in this if you want to contribute to the Ocean Decade. The way that we're trying to do that is using the GCOOS framework for ocean observing, which is this diagram here, where GCOOS and nations or conventions define requirements. GCOOS, the Marine Biodiversity Observation Network, and other groups that are do observing collect these observations and standardize them and push them into databases like OBIS, where you can harvest them to make indicators and other products, such as what we're trying to do under Marine Life 2030. Anyway, that's in short the story that I have to tell you today, and thank you.
Thank you, Frank. We're going to open it up for questions. Anybody has for Frank? We have a few minutes. You can either raise your hand, write them in the chat box. Just this, we're such a small group. If you want to come off mute and ask it, that's fine.
Hi, Tom. Yeah, go ahead.
Thanks, Frank. I really like the talk, and there is a plethora of information in there. When it comes to the satellite data that you worked with Maxar and Digital Globe on, is that a pay-for service, or were they offering that as an academic research tool that you kind of sold to them as a way for them to get more exposure?
It's a little bit of both. You know, all of these companies have some academic program, but also the government a license for research purposes. That is, it's a kind of a blanket license, you know, for if you have a grant by NASA or the National Science Foundation or NOAA or you know, the DoD, you can request access to this license and get access to the data. The interface to get the data under this license is restricted. You know, you can get data, for example, only for the United States, okay? Unless you have very special requirements and requests, and you can open that up. However, that's through the Maxar interface. Planet has its own interface and academic license program, but under this government license, it's very broad. You can get anything and everything, and it's pretty amazing. And NASA has been harvesting the data from Maxar, and so they have their own copy of the data under a commercial agreement for research that is sponsored by NASA. Okay, so if you have a NASA project, you can get access. The interface to get the data is horrendous, but you can get it. Okay, and that is all the data, really almost without restriction. But it is a massive amount of data, as you can imagine. So we don't pay for it.
Sure.
We're not supposed to distribute the images or anything that looks like an image, but we can distribute these value-added products. Okay, so derived maps, land cover products, things like that are totally open for distribution, but not the images themselves.
Another question, if I can. Your IMARS team, you're made up of students too, right?
Yes.
You have students, okay. Are you getting a good, I guess, a good student base, a good student population that comes in specifically to work with IMARS?
Well, it varies from year to year, but we do have a lot of people that are interested in coming to USF and the College of Marine Science. And so we don't get enough students that are really interested, that have the background, for example, the background in programming and multiple languages or open source programming. We still have to train our students into in the art of doing all of that. So yeah, more and more you see students that come with a a base in especially R, Python, and things like that. But it's not a huge influx of students that have that capacity. But if they're interested, they'll learn. And so this is not at this point the tools available to manipulate and use satellite data are so open and so available, and the data is so easily accessible that it's a very different world from when I started a, a couple years back.
Have you done any work on just describing or documenting the foundational knowledge that's needed for students, or even maybe high school education, in order to better prepare students for um, what it will take to develop those skills earlier in your academic life?
Not in that many words. We have gone, Tom, to classrooms. We have webinars that help people understand that, the most important thing that you can come with is to be interested in looking at this from a scientific point of view, and being ready to handle massive amounts of data. And the rest comes if people are interested in that. But there has to be at least a minimum of interest in programming and using computers. Now, some people are afraid of that or not interested in that, and so that there are tools that we're making that make it easy to be just an end user. You get the time series, you look at the time series of temperature, chlorophyll. So that's another possibility. We need people to use the data, and not everybody has to know how to process all the data. So you do need experts in that, especially moving forward as we get into more complicated satellite data like the hyperspectral sensors that are coming pretty soon. We have some already, but global hyperspectral data will come starting next year with a PACE sensor from NASA. And so you do need a group of people that understands that and is able to process that. But really, not everybody needs to do that. And if you have products that have been validated, proven, if we can demonstrate that through scientific inquiry and validation, then people can use the data with some degree of confidence. I mean, as with any data, people should know what they're looking at, or you'll fall into any number of traps. But I think that there's a lot to do here without having to know all about satellites, and without that technical expertise. So, but it's a good point. No, it's good for people to know what do they need to be prepared for if they get into a specific area in grad school.
I think you're going to have to ask that
That's right.
question again after Nan's presentation, and then they're going to have to collaborate on how to make that foundational paper come to fruition. We've got time, Code, got one more question from you, and then we're going to move on to Nan. So go ahead, Bob.
Okay, not really a question so much as an observation. Great talk, Frank. I really enjoyed it. But Tom, to your question, that subject has been a matter of great debate in the national DMAC working groups and dealing with that data. And not to go too deep into the weeds, but I think we're currently coming to the consensus that it's easier to take a trained data scientist, a data munger, and school them on the type of oceanographic data they'll be working with than to expect every up and coming oceanographic early career person to keep up with the tools, because they just change so rapidly that it's a career in itself to do that. So it's really going to be a collaborative effort in the future, I think, with a couple of hardcore data people embedded into somebody like Frank's team providing that support.
But let me react to that very quickly, because it's not just students that you need to have to understand the kind of data that we have, but we're trying to work with the National Marine Sanctuaries managers, for example, or fisheries people, or anybody that is just interested in understanding how is stuff changing out there, and can you tell me if it's affecting my resource or how I use the ocean? And so for them, some of these tools, like these portals, are extremely complicated, and they say, well, I can't get in there and duplicate what you showed me. So they would like to have a simple cartoon with a silhouette of a fish that they're interested in or a coral reef. They click on it and they see how it's changing, right? They see a thermometer, they can see how things are changing for the area that they're interested in. We found that in working with the people that just don't have, they have their own jobs, they have their resource management efforts that they have to deal with. And so we need to find a way to push these products out in a way that is useful for a larger number of people and not through complicated interfaces or expect everybody to be an expert programmer in R, because they're not and they don't need to be.
Thanks, Frank. And if there are any other questions for Frank that you didn't get to, please put them in the chat box or feel free to follow up with us after the webinar as well. We'll put that in there for you. Thanks everybody for the great discussion. Thanks, Frank, for that great presentation. Next up, we have Dr. Nan Walker. In addition to being a valued GCOOS board member, Nan's a professor and the James P. Morgan Distinguished Professor in the Department of Oceanography and Coastal Sciences at Louisiana State University, where she's been employed for more than 30 years. Since 2003, she's been the director of the LSU EarthScan Laboratory, and her work is focused on using satellite data to study coastal and oceanic processes, especially physical processes and air-sea interactions. Among her research interests are processes that impact hurricane intensity changes, estuarine shelf exchange processes, surface sediment transport, coastal upwelling, and ocean climatology. Nan is also an adventurer at heart. See, I learned something new about you this time, Nan. After completing her PhD in physical oceanography at the University of Cape Town, she spent 2 years sailing her 32-foot sailboat from South Africa to the Gulf of Mexico, and she detoured for 6 months to the West Indies Marine Lab in the U.S. Virgin Islands to study corals in St. Croix following Hurricane Hugo. And today she's going to present to us an overview of the satellite imagery her lab produces daily and applications for this imagery that they've created. And her talk is titled LSU EarthScan Lab Satellite Image Products for GCOOS. So all yours, Nan.
Thank you very much, Chris. And thank you, Jen, for running my presentation as well. At LSU, we had an internet outage for almost 2 days this week. So we decided it was better if Jen could run my presentation for me rather than depending on our internet. Anyway, thank you everybody for coming today. I'm going to be talking to you about the LSU EarthScan Lab satellite image products that we're creating for GCOOS currently. As Chris said, I'm the director of the EarthScan Lab, and I'd like to acknowledge the systems manager, Rick Haig, for all his work in image processing and running the IT for the lab over many years since 2006. We're affiliated with the Department of Oceanography and Coastal Sciences at Louisiana State University in Baton Rouge. The lab was founded by Oscar Hugh in 1988. Oscar was a true early pioneer in satellite oceanography and meteorology. He was my mentor for my master's degree at LSU in the early 80s. Just to give you a little background how I ended up as director. And then after sailing back from South Africa, as Chris mentioned, I ended up back at LSU, and he encouraged me to come back and work with him in his newly created lab. So I arrived back in about 1991, and I've been here ever since. And when he retired in 2003, it was unfortunate. He got Parkinson's. Then I took over as the lab director, and Rick Haig has been in the lab with me this whole time. So from the early days, the lab mission was education, research, and emergency response. Living in Louisiana, emergency response, often takes precedence over the other two, although obviously at a university, education and research are paramount. Oscar founded the lab mainly because he was frustrated with not being able to get satellite imagery when he wanted it. He had trained with the Navy where he ran real-time programs with remote sensing. And so he met Buzz Bernstein in California in the 1986 or 87. And Buzz Bernstein had put together an awesome company called Seaspace Corporation, which basically had developed or instrumented real systems with antennas and computers and receivers, which allowed researchers to access satellite imagery in real time and process it with the software that C-Space provided. So it gave easy access to researchers to processing satellite data in the early years before the internet. And so Oscar became well known for tracking hurricanes for the state of Louisiana. And we were lucky enough to apply for a lot of state funding, which built the lab from 1988 when we only had an AVHRR antenna, which you see in the top left of this figure. And then the next capability we got was with funding from the Office of Emergency Preparedness for the GCOOS satellite. So the GCOOS allowed us to track hurricanes every 15 minutes in near real time. And also I started using it for tracking ocean currents in the Gulf of Mexico, specifically the loop current and warm and cold core eddies. We also had an X-band high-speed tracking antenna, which we acquired in the early 2000s for tracking MODIS, and an Indian satellite called OceanSat OCM, which provided chlorophyll A imagery, and VIIRS, which you've probably heard of, one of NASA's newer sensors. So I would like to overview today exactly what we're doing for the GCOOS project. Jen, could you proceed to the next slide? Okay, so our image products include the following. So we're producing what we call a declouded sea surface temperature image from the newest GCOOS geostationary sensor called the ABI, the Advanced Baseline Imager. And I'm going to talk more about that in a moment. The MODIS True Color imagery, where we have more than 10 coastal areas that we're covering. The Louisiana coast has been covered for some time, and then we started covering 8 new areas around the Gulf. So we pretty much have the whole Gulf of Mexico coastline covered with satellite imagery, which is updated daily. And so one can download that and create your own animations of your favorite area. This includes the Mexican coast. So also we've been creating integrated products using the GCOOS SST, the declouded SST, and Bob Laban's sea surface height data. And these two products together are very powerful in monitoring the loop current and eddy interactions. And I'll show you some recent examples in a few minutes. Another integrated pilot product that I'm interested in and have just been able to put together a few pilot images is integrating the GCOOS SST with some of the HF radar currents that are being collected around the Gulf of Mexico. And I'll show you examples from Stephen Howden's system off the Mississippi, Louisiana, Alabama coast, and also the GCOOS system off Texas coast. On the Earth Scan Lab website, you'll find on the front page something we call Image of the Week. We don't promise that we update it every week, but you'll find there some interesting images that we've come across and an explanation of what they're showing. A lot of my work and the work of the lab is event related, so we cover disasters basically. I think I'm the queen of disasters. I've studied so many of them. Anyway, so I'll show you that Image of the Week page in a few minutes. And also we write articles for the GCOOS newsletters. So all of this is part of our GCOOS funding. Next slide, please. All right, so in addition to the daily data that we're looking at and provided to GCOOS via our image archives, we have extensive long-term archives from various satellite sensors. The longest archive is from the geostationary satellites called, the sensor is GVAR, GCOOS variable, and this is, the archive lasts from 2000 to 2017. At that time, GVAR was replaced by the ABI sensor, which is what we currently use, and the spatial resolution you'll notice in this listing improved from 4 by 4 kilometers to 2 by 2 kilometers. So the pixel size improved dramatically. The GCOOS ABI sensor is just a truly amazing sensor. It's so that's geostationary. So it's it basically hovers over the Earth, over the equator in 75 degrees west, and it senses a huge area of the Western Hemisphere every 5 minutes. So I'll be talking more about that. The MODIS archive goes back to 2006. So that archive is mainly the Louisiana coast. Like I mentioned just recently, we started covering more of the Gulf of Mexico coastline. We have archives of the OCM data, which is chlorophyll A, over an 8-year span. You can see there from 2002 to 2010. VEER starting in 2016, and NOAA AVHR starting in 2009 to 2017 when we had an antenna failure. So I'll be showing you how to access this data. I think that's really important for the users to know that. Next slide, please. Okay, so the Gulf of Mexico is very cloudy. If you look at any individual synoptic images, you'll likely see a lot of clouds. So very importantly for oceanography, especially for tracking the loop current and the eddies, is to get rid of the clouds. So the way that we have done this is in 1988, we started using a cloud clearing technique. And the way this works is we take a sequence of about 10 nighttime images, well, 10 hours of nighttime images from the GCOOS satellite. And with the GVAR sensor, this was approximately 20 to 40 images. We use the 4-micron channel, which is what we call the mid-infrared channel. It looks through the water vapor a lot better in the clouds, so it gives you a better chance of seeing the ocean pixels. And so what you see here is the top panel is showing you the input images into the cloud erasing technique, and the bottom panel is showing you how that technique works to get rid of clouds. So basically it retains the warmest pixels within that sequence of the warmest pixels across that whole area over the time period. So it's replacing the cold cloud pixels with warm ocean pixels. If the clouds do not move, it does not work as well as if the clouds are moving. So if there's a stationary front, it won't work very well. Anyway, that should give you an idea of how it works. And now I'm going to show you the imagery that we're getting from the ABI sensor using this technique. Next slide, please. Okay, here you see a panel of 4 of the GCOOS ABI declouded SST imagery. And this, the 4 panels are December 23rd, December 28th, January 6th, and January 12th. So this is showing you the detachment of the most recent warm core eddy, which was named Zodiac by the Horizon Marine Group. So the panel just shows you the detachment that happened about December 28th. And then you can see the warm core eddy moving away from the loop current a little bit, not very much over time. So what you can see is there are very few clouds in these images. I've actually annotated some clouds in the top left panel. So you can see the clouds that remain are usually either a black color or a blue color. We're in the process of trying to mask the residual clouds, which I think will help with, users that aren't as can't discriminate clouds from ocean with their eyes, don't have that experience. So hopefully within a month or so we'll have that declouding process operational. Next slide, please. Okay, so next I'd like to show you an animation of these declouded SST images. Again, these are the nighttime composites. So this sequence is from December 28th, which was when the warm core eddy zodiac detached from the loop current, and it extends to January 13th. So they remain detached for that period of time. So you'll see a lot of detail around both the eddy and the loop current associated with cold core cyclonic eddies. So these features are smaller than the warm core eddies, but they're always present and they move very rapidly along the edge of the loop current, and also they get transferred to the warm core eddies when they are detached. So that's one of the features that I've been interested in, because animating the GCOOS SST images used to be one of the only ways of tracking these eddies, because the altimeters in the early days didn't do a very good job. Next slide, please. Okay, this is the most recent of the GCOOS SST ABI images. I just downloaded it this morning from our webpage, and what you see is a reattachment between the loop current and the warm core eddy. Again, you'll notice how few clouds there are in this image. This is Bob Laban and I have been, watching these events every day for a while, because so many things are happening very quickly around, associated with the loop current and this warm core eddy, and we are constantly amazed at how clear these images are. So much better than the GCOOS GVAR images were. Next slide, please. Okay, now I'm going to share with you an animation that Bob Laban put together. He overlaid his sea surface height data upon the sea surface temperature data. Our sea surface temperature, we create a nighttime image, as you know, and his data is a daily image, so it's really easy to combine these two data sets. And what's happened, as you saw in the last image, is there's been a reattachment of the loop current with this warm core eddy zodiac. Now this animation is from mid-January to February 26th. It's running so fast that you're not seeing all the panels. But when I saw how fast it was running, and Bob says he doesn't, unless you download it, you really can't get it to run at a lower rate of speed. So what we're going to do, since this is a new animation, is to add it to the image of the week page on the Earth Scan Lab website, so that all of you and others can download it and look at it at your leisure. So we'll be keeping an eye on what's going on with events in the Gulf, and have been for many years. In fact, Bob and I started working together in the early 90s on an MMS project. So we've been collaborating together for some time. Next slide, please. Okay, the last ABI SST data I want to show you is just, this is from February 26th. Again, we're still looking at eddy zodiac and the loop current, but I just wanted to point out the advantages of having both the overlay of the sea surface height on the sea surface temperature, as well as the sea surface temperature on its own, because when you overlay the sea surface height, it kind of masks a lot of the details associated with the features that you can see in the sea surface temperature images. Okay, so let's move on to talking about the MODIS true color images. So here okay, so as I mentioned, we have a lot of, most of the Gulf of Mexico coastal areas are covered on our webpage now. There are federal websites that provide you the access to this type of imagery, but to me, it's nice to have the images already in the format you can just download and look at on a daily basis. As I mentioned, our webpage is updated every day with both images from Aqua and Terra. So we use this imagery for looking at episodic events, such as flood events along the Louisiana coast, like the Mississippi River flood of 2019, as well as the many flood events we've had in the last decade, like an abnormal amount of flood events. Also, you'll notice in the right-hand panel, there's an image of the west coast of Florida after Ian hit, and there's large discharge plumes, which resulted after when the floodwaters receded back into the Gulf. So the right-hand panel was covered in a newsletter article to GCOOS with Frank Muller-Karger was included as a collaborator on that. So basically, I think these true color images should be really valuable for, looking at impacts of storms or floods or harmful algal blooms even. The MODIS True Color can pick up. One really nice thing about the MODIS True Color is the combination of the red, green, and blue channels mimics what your eye sees. So it's like a true color based on the world we live in. Also, the clouds are just naturally white. So one doesn't have to work very hard to mask the clouds because the enhancement just reveals where the clouds are naturally. Okay, let's go on to the next slide. The last thing I want to show you is how is a pilot project that we have looking at integrating GCOOS SST with the HF radar currents. So I'm going to show you an example. The first example that we have, the radar currents were provided by Dr. Stephen Howden at USM. And so we have one nighttime SST image from the declouded image, as I spoke about. This is an October 2nd image, and the image is like an integration of the nighttime it's a nighttime composite. So we have a lot of HF radar data over that nighttime image. So we've just chosen 1 hour to overlay. And you'll see there's a scale for the radar currents in the bottom left. It's 0.5 meters per second, so that's about 1 knot. October 2nd was a couple days after Hurricane Ian hit the west coast of Florida. And you can imagine that the winds impacted this area of the Gulf as well. I know that looking at the SST data, there was a lot of cooling of the shallow coastal waters from Ian, and it looks like there were very strong currents that were still, flowing away from the coast, according to these currents you see in this composite after that storm. Let's go to the Texas shelf now. Okay, so this is the radar currents for the same night on the Texas shelf, and you'll notice the very strong currents entering the bays after that event. So we haven't really analyzed this data. We're just, providing it as a pilot project to see if GCOOS is interested in having this kind of integration of products on a regular basis for their viewers, for their stakeholders. Okay, so now I know I don't have much time left, but I want to take you to the EarthScan Lab website and show you how to access these imagery. So Jen is going to take us there. She just has to share the screen to bring up the EarthScan Lab website. Okay, so here's the front page of the EarthScan Lab website. So in the top left corner, you'll find an atmospheric animation. It's a real-time animation. She's just going to click on it to enlarge it. It doesn't look like it takes a little while to upload, possibly. Anyway, there we go. So this is the current weather that's being experienced over the Gulf of Mexico. This is created from 3 bands of atmospheric water vapor data. You can see clouds, and the water vapor areas are kind of white compared to the drier areas, which are dark. Okay, Jen, can we look at the image of the week? All right, so if you scroll down on the page, you'll see where we post the image of the weeks. So this is the last one posted about the detachment. So we'll go ahead and post something on the reattachment. And then if you scroll down again, you'll see some older image of the week postings on the flood of 2019, and then the new regional coverage of the Gulf coastal regions for GCOOS, which is showing up in the middle of the page. Okay, so when the image of the weeks are taken off of this page, they end up under image archives. So Jen, could you skip over to image archives now? She's going to show you how to get there. So from the top panel, you choose imagery archives. Okay, and here's where you'll see the names of the sensors. So if you want to access the GCOOS SST, you click on ABI, which is the top, okay, and click on nighttime GOM, nightly GOM SST. And that's where you'll see the SST panels will show up. The most recent will show up, and you can scroll through the calendar archive to access any of the past data that we've collected. And there should be an image for every date. Okay, so let's show the viewers where the MODIS archive is. So it's also under Imagery Archives, and we go down to MODIS, and then if you want to look at the regional true color is all the different coastal panels for the Gulf of Mexico, as well as a whole Gulf image. But the coastal panels are going to be of most interest. So if you click that, Jen, and just open it up for the viewers. Oh, it looks like the 28th has been filled in. That's what's showing here, I guess, the 28th. Okay, they just got that up. So if you scroll down, you can see there's the Yucatan Peninsula and the West Florida Shelf. You should see the Northwestern Gulf and the Northeastern Gulf. So those are updated at least once a day, sometimes twice a day. So feel free to grab those. You can download those. Also, we intend to provide geotiffs of these in the near future. If anybody has questions or has a particular format to request, please let us know. And then one other thing I wanted to tell you about is that the image of the weeks end up at, if you scroll down to Imagery Best of EarthScan Lab. So that's also under Imagery. Oh, at the top, Best of EarthScan Lab. Okay. So that's where the image of the weeks end up. And also I called to your attention the ocean animations and atmospheric animations. So these are, and also the Deepwater Horizon page. So you might want to check these out. They're basically historic animations of hurricanes and air scenery, like cool wakes from hurricanes and that kind of thing. Very, very useful for educating students on what's happening in the Gulf of Mexico. Well, I'll end there and thank you for your attention. Sorry I ran a little late. And I'll be happy to answer any questions. Thank you so much.
Thanks, Nan. We are up on the hour now. If there's anybody who has one short question, we could take it. Otherwise, you are welcome to send us follow-up after the webinar and reach out. Code, I see your hand is still up. I don't know if you have a question now or if that was from before.
No, I have a brief question for Nan. Again, great presentation. Are any of those images available as geotiffs? I saw several that would be great for Gandalf, but they really need to be in geotiff format.
Yes, we used to have the geotiff format for the true color images. NetCDF is what we usually can provide. That's the easiest thing for us to provide for the SST images. So which ones were you interested in particular? or do you want to just, you can send me an email if you prefer.
Yeah, we can take it offline so we don't hijack
Okay.
the meeting. But I did see several that I'd love to have up on Gandalf.
Okay, great. Glad to hear it.
If you want to stay on for another minute, I'm going to just thank everybody for joining us, but there is another question in the chat box for those who want to stay. We hope to see you next week. I want to thank Frank and Nan for today's presentations. They were great, very informative. And next week, we're going to hear from Dr. Eric Milbrandt and Dr. Chuan Minyu. They'll be talking about water quality that they're being funded to do. I understand those who have to drop off if you need to, but Nan, Frank would like to know how you see the long-term plans for the EarthScan lab.
Okay, well, that's $1 million question. Since I do plan on retiring someday, and so does Rick, unfortunately, the systems manager, that's I don't have a complete answer to that. I would like to say that, you know, it's going to continue. We have some new faculty at LSU that I think are very interested in taking on the challenge. Although you know as well as I that the field of remote sensing has changed so much in recent years that it's, you know, no longer do we use our antennas. We get everything from, you know, from the archives from NASA and NOAA, which has its pluses and minuses. It saves us money. We don't have to maintain our antennas. But sometimes you have to wait on delayed response from, you know, from federal labs. But anyway, so things have changed a lot. We have a new meteorologist on staff, and I think he might be interested in, you know, taking on, you know, like maybe taking it more of a meteorological focus. And Eureka Desa is here, and so he may like to expand in the realm of ocean color. So, because we haven't been as active in ocean color as you have. So I think I'm hoping that, you know, someone will keep the archives going. What I plan to do with the archives is create like a year-long animations so that, you know, those images don't get lost. Because one thing I didn't say is they're very useful for grad students or any students really. Like anybody interested in coastal circulation, you can look at those imagery and especially animate them and see, you know, the Mississippi plume, where it's going. Is it, you know, you can learn something about wind-driven and tidal-driven fluxes by watching those animations of these features. They're so, you know, it's just my passion has always been, you know, looking at the satellite imagery and what does it tell us about ocean processes. So, you know, I hope that they'll continue it. I don't expect to be involved forever. Although so far I have been, so over 30 years. Anyway, but I really enjoyed your presentation, Frank. I thought that was, you're doing great things. A lot of energy put into that, into getting people organized. That's a challenge.
Yeah, Nan, well, thanks for doing what you're doing too.
Oh, thanks.
A big question because we've tried to see what do you do with these archives, and you know we've been operating antennas here since I don't know, this is a long time since we had ADHRR data way back when, and it is so much data that people don't want to pick it up. Like we've tried to work with other groups that archive oceanographic data, and they don't want to take it. You know,
Mm.
and the AVHR data is not archived anywhere. Well, now the GRIST program has we passed them some data, so hopefully that's all embedded there. But yeah,
Yeah, well, there's the Pathfinder series. So, but you're talking about the archives that you've developed, I assume.
at 1 kilometer, yeah.
Yeah, yeah. I mean, in the early days, you know, labs like ours were being begged to give the federal labs data. They came to us for data. Yeah, it's a shame that somebody isn't interested in that. We have something called CCT at LSU. It's the Center for Computational Technology, and a long time ago they got, well, they have lots of money And so I'm hoping that maybe, you know, through faculty that we have in our department who are co-funded through that group, maybe we'll be able to archive our imagery there. But I don't even, I mean, I don't know about you, but, you know, we have archives that are on various formats, you know, like tapes that we can't even read anymore. So, you know, I'm more interested, I guess, in archiving the imagery that we created, because if you have access to that, then you know where to look in the federal archives for that data.
But
You
the
know what I
problem is
mean?
that the early AVHR data, we were the only ones collecting it, just like
Yeah,
you.
yeah,
And so we passed the CWIFS data, and NASA picked up the CWIFS data, but nobody wanted to pick up the infrared data from
right.
these antennas. And so that data is going to be lost eventually. We managed to move it from media to media, and so we have it. But you know, at some point that may be lost because
Yeah, maybe maybe talk to Rick Stumpf. Maybe he has some ideas because he's a long-term user of AVHR, you know, and he's at Nes. Well, I don't think he's in Nesnus. I could be wrong.
this and
I live
and cost.
in NCOS, yeah, but
What about NCEI?
No, they don't take it. They don't want it.
uh, hmm.
Mm.
Yeah, that's a pity. Um, we have we have a lot of that as well in our archives, but
Is
yeah,
that a conversation we should try to host with with the Federal Advisory Committee? And
It
maybe
could
put
be.
out
I
some.
mean, maybe Philemon has a point because I mean, this I tried this 15 years ago. Maybe people have changed, the computers and storage has changed, and so maybe they can reconsider that. So maybe it's a good idea, Chris and Philemon, to pick it up. Definitely. But we're not the only ones. And there were antennas like this, you know, around the country and around the world.
Or maybe even the ESIP board, Philemon. Maybe that's a dialogue to just open up with them and just kind of fish for ideas of what might be done.
yeah,
Yeah, because I heard that this problem is not uh, uh, it's a worldwide problem really. The Germans are having issues as well, the Brits of course, and we have the same issues here. Has something to do with the availability of storage spaces. And since NCEI has just recently upgraded its system to multiple of petabytes and zettabytes of storage, probably these kinds of data can actually be absorbed now. But I'm making a note here. I will check with NCEI and see whether or not they have changed their uh, what they call this. They have changed the rules with regards to these kinds of data. Yes, I will check them, Frank, and then I'll get back to you
Oh, it'd be
once I hear back.
fantastic. Thank you.
yeah.
That'd be
Maybe Frank can get his AVHR data archived, and maybe I can get the GCOOS SST data, the declouded SST data archived. That would be awesome.
Yeah, I mean, the advantage, you're right that the images are good, but the actual, I mean, there is actual
Yeah,
data. And so
right.
some of these time series, if you can extend them back into the 1980s, you know, that'd be wonderful.
Yes. So yeah, one thing I was going to mention is I haven't really been working a lot with climate data like you have. Um, we did work a little bit with the last GCOOS, and we had an SST climatology, but when you can't really create a climatology with the warmest pixel composite image, because it's going to be, you know, different than a mean composite image. So um, but anyway, like I've mentioned in the talk, most of my work has been related to events, not climate, in the last 30 years. But yeah, they're both very important. So, well, great. Well, this was fun, except for
Thanks for coming.
except getting ready for it wasn't much fun because of all the internet glitches. But anyway,
Doesn't
uh,
your 30 years add up to climate?
yeah, right. I feel like it. Oh my.
Well, thanks
Anyway,
again to everybody. Frank, Nan, has been really insightful. I appreciate everybody staying on a little bit extra. I think the dialogue's been really useful, and hopefully we can find some solutions to the challenges that, or at least start the dialogue on
great.
finding some solutions.
We'll stay positive.
Yeah.
All
Thank
right.
you. Thank you,
All right.
GCOOS. Thank you, Jorge,
Thanks.
Chris,
Thanks,
and Jen.
guys.